Hey everyone, and welcome. Today we're tackling a really interesting problem called number of people aware of a secret. It feels a bit like a simulation puzzle, where we need to track how information spreads and eventually fades away. Let's break it down together. So here's the setup. We're given a total number of days, which we'll call n, kid. The story starts on day 1 with a single person discovering a secret. Now, there are two important rules. First, there's a delay, saokibol. A person has to wait for delay number of days before they can start sharing the secret. Once they can share, they tell one new person every single day. The second rule is, forget. After forget number of days from when they first learned it, a person completely forgets the secret and stops sharing. Our job is to figure out, at the very end of day n, exactly how many people still know the secret. Let's think about the journey of a single person. When they first learn the secret, there's this initial waiting period. They're in on it, but they're quiet. Once the delay period is over, they enter the sharing phase. Every day they bring one more person into the loop. But this doesn't last forever. Once the forget timer runs out, their memory of the secret is gone, and they're out of the game. It's really important to focus on the final goal. We're not counting the total number of people who ever knew the secret. We need a snapshot right at the end of day n, who, at that specific moment, still remembers. That's the number we need to find. Let's walk through the first example to see these rules in action. On day 1, person A learns. They have to wait 2 days to share. So on day 3 they tell person B. Now we have 2 people. On day 5 2 things happen. Person A, who learned on day 1, forgets because 4 days have passed. But person B, who learned on day 3, has now waited 2 days and starts sharing. It's this handoff, this chain reaction, that is the core of the problem. Following this logic to day 6, we find that 5 people know the secret. This problem involves states that depend on previous states, day by day. This is a classic sign that dynamic programming is a good approach. The key to any DP problem is figuring out what state to track. Instead of trying to follow every single person, which would get complicated fast, let's just track a single number for each day. How many new people found out the secret on that specific day? We'll store this in an array, which we'll call DP. So to figure out how many new people learn the secret on, let's say, day I, we need to know how many people are actively sharing on that day. And who are they? Well, they're the people who learned the secret long enough ago to pass the delay, but not so long ago that they've hit the forget limit. This gives us a specific window of past days, and the people from that window are the ones spreading the secret today. Now, we could calculate the sum of sharers from that window every single day, but that's inefficient. A much smarter way is to use a sliding window concept. We'll maintain a single variable that holds the current number of active sharers. As we move from one day to the next, we just update this count. We add in the group of people who just became eligible to share, and we subtract the group who just forgot. This is way faster. Alright, here's what that logic looks like as Python code. Don't worry if it looks like a lot at once. We're going to step through each part. First things first, we set up our variables. We define the modulus, which we need for the final answer. Then we create our DP array to store the number of new people for each day, initializing it all to zeros. The most crucial part is the base case. On day 1, exactly one person learns the secret, so we set the value at index 1 of our DP array to 1. Now for the core of the algorithm, we loop from day 2 all the way to our final day, nihuna bands. We use that share variable we talked about to keep a running total of active sharers. On each day we check, have delay days passed? If so, we find the group of people who learned back then and add them to our share count. Then we check, have forget days passed? If so, we find the group that learned that long ago and subtract them. This updated share count is exactly the number of new people who learn the secret today, so we store it in our DP array. After our main loop finishes, the DP array is filled out. It tells us how many new people learned the secret on every single day. To get the final answer, we just need to sum up everyone who hasn't forgotten by day n, upahisi. These are the people who learned the secret sometime in the last forget number of days. So we loop through that final window in our DP array, sum up the values, and that's our answer. So how efficient is our solution? We have one primary loop that runs n times, where n is the total number of days. That makes our time complexity big O of n. For space, we create that DP array which also has a size of n, so our space complexity is also big O of n. Pretty good. So to wrap it all up, this was a great example of a dynamic programming problem. The key was to simplify the state we were tracking down to just the number of new people per day. From there, we used a clever sliding window idea to keep our calculations fast and efficient. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the Playlist tab and find a playlist that fits your goals. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. This channel doesn't make any money from sponsorships or ads yet, so if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.